Good afternoon, everyone. It is my great honor to have this opportunity to report my study. My presentation is about Banerjee-Tarski paradox. Judging from this name, it sounds a little bit complex. So before we explain this paradox in detail, let's look at a simple example to see how to create a piece of chocolate out of thin air. Suppose that there is a chocolate. We only need to cut three of them and divide it into four pieces. Only move three of them, then we can form a new great chocolate. And deduct one chocolate is created out of thin air. In this way, by repeating this big step, we can get infinite chocolate. This muscle seems to be flawless, but in fact, it is just a blinding muscle of mathematical principles. The recombined chocolate is shorter than the previous one, but the change is too little that can't be observed by our eye. After all, it is impossible to cut chocolate in this way and rearrange the pieces same as the original one. But what if this kind of thing can really happen in our life? This is a topic we are going to discuss today, Banerjee-Tarski paradox. It proves that there is a way to take an object and separate it into five different pieces, and then simply rearrange them. No sketching required. We can get two exact copy of the original item. In geometric language, it's first assumed that there is a solid sphere in three-dimensional area. Then there must be a way to divide it into finite parts, and just by rotating and moving it back together to produce identical copies of original ball. Moreover, the two newly generated ball has not only the same volume as the original solid ball, but also have the same properties in density, mass, and so on. In order to better understand this process, we also need to understand what is infinity. The Hilbert Hotel gave us a good example. Suppose there is a world hotel named Hilbert Hotel. There are countless homes in this hotel, and each room has a guest. So it seems that all rooms are full. However, if a new guest wants to stay in this hotel room, then just let guests in room 1 move to room 2, and guests in room 2 move to room 3, and so on. Since the number of rooms is countless, the guests are able to move to the next room. So in this way, room 1 becomes empty, and the new guest can live in the room 1. Back to our Banerjee-Tarski paradox. The most important part is how to split the three-dimensional area. First, select a point O on the sphere. Starting from this point, it can move in four directions of up, down, left, and right. Every time point O moves one direction, one step is recorded. As long as the appropriate length is selected, no type of travel will go to the same point unless the original pace returns. Since there are countless points on a sphere and each point has countless kinds of moves, it is necessary to list all the moves of possible points. In order to describe these point moves intuitively, the above sequence needs to be divided into four categories: U, D, L, O, and we can give them some colors to observe their moves easier. In addition to the above four types of points, there is only the starting point and the poles repeatedly recorded on a sphere. The pole means that when a certain point reaches the position of the extreme point, there is no up, down, left, or right. That is, it can't continue to move, and it needs to be marked separately. Finally, we get a sphere consisting the U, D, L, O as the starting point and pole. Now we get a rough ball with the boundary. At this time, take all the points of U class separately and rotate it down one step to get parts corresponding to U class, L class, O class, the starting point. This is because the downward rotation offsets the upward rotation of the last step of the U class, and the remaining parts can still form a sequence representing the U point, L point, and O point. These points that have only taken one step U are cancelled by D and revert to all starting point. In this way, with just one rotation, we get 4 parts of the sphere, and the remaining part only need to filled with d point part and the pole separated before. The center of the ball is put into it, which is complex sphere. Using the same method, another complex sphere can be spelled out. And the pole and the center of sphere can be solved by using the idea of Hilbert hotel, because each circle have each pole, and there will not be multiple poles on the same circle. Only need to find another point to supplement the vacancy of the previous point in order to get a complex sphere. Now, it has been possible to successfully divide a ball into two, and those two balls actually have no difference from the old one. So far, this theory may be still controversial. Many scientists believe that Banerjee-Tarski paradox is just a mathematical theory, and this is impossible to apply in our real world, because they think it is impossible to divide a ball into infinite sets of points. But some scholars have suggested that Banerjee-Tarski paradox may be achievable. Augustine said that teeny particles can become more particles when they experience high-energy collisions, which means the paradox can be true in biological and physical fields. In a word, perhaps when humans truly understand the meaning of infinity and apply the concepts of infinity to life, Banerjee-Tarski paradox can become reality. Thank you.